All right, you guys, today we are doing a little review on circles. We're looking at our Quiz 6 review. All right, so first up, I'm saying let's write the standard equation of the circle and then find the center and its radius. So the first thing that I like to do is reorganize all of my components. So I have the x's together, the y's together, and the constant on the other side. So I'm going to go ahead, I'm going to add the 9 to the other side and rewrite this as x squared minus 8x plus y squared plus 10y is all equal to 9. Now from here I'm going to do that process of completing the square, and when I'm completing the square I'm creating a perfect square trinomial. Anytime we have a perfect square trinomial, it factors into a binomial squared. All right, so I'm looking at this negative 8, the linear term. I'm going to split it in half and square it. So I'm looking at negative 4 squared, and that's going to get me 16. I'm going to do the same thing with the y. Split it in half, write the linear term on the y. So I split that 10 in half. That's going to get me 5. And when I square it, it's 25. So now on the left, I'm going to write my equation as x squared minus 8x plus 16. I'm going to underline that to draw attention to it because that's new. I've added it to the left-hand side. And then y squared plus 10y plus 25. Again, I'm going to underline that because it's new to the left-hand side. And then equals 9. Now, what I've added to the left, I can't just add it to the left without balancing it. I have to make sure I add it to the right as well. So I'm going to add the 16 and the 25 here as well. So again, it's always a balancing act. I cannot just add to one side of the equation. I have to make sure that what I do to one side, I do to the other side as well. So now, what I have here is a perfect square trinomial. Here is a perfect square trinomial. And anytime we have a perfect square trinomial, it factors into a binomial squared. So here I know that that is x squared, that's 4 squared. If I multiply the x and the 4 and I double, right, it gets me what's in the middle. So this is going to factor into x and 4 like that. The negative goes here, travels down with it. So this is x minus 4 as a quantity squared. Over here, looking at the y squared plus 10y plus 25, right, perfect square here, perfect square here, y and 5. Multiply those and double, it's what's in the middle. So we can confirm that this would be y plus 5 as a quantity squared. Put that plus back in the middle. And then if I add up the 9, the 16, and the 25, that's going to sum to 50. So here is my equation right here in standard form. And now I can identify my center and my radius. So my center will be 4, negative 5. And my radius will be the square root of 50, which is 25 times 2, so 5 root 2. Okay, so next up, here I'm giving you an equation of a circle. It is in standard form, and I want to find the center, the radius, the x and y intercepts, and then I want to graph it. All right, so first let me just write that standard form beneath it, right? This is x minus h squared plus y minus k squared equals the radius squared. Okay, so my center is at 3, negative 4. My radius is going to be the square root of 20. Well, 20 is 4 times 5, so I have 2 root 5. And I'm going to need the decimal approximation to be able to graph it. So that's about 4.47. Okay, now I'm going to need my intercepts. So let's get the x-intercepts first. We should know that they occur when the y value is 0. So if I plug in a y value of 0 right in here, right, it's just going to become 4 squared right over here. So right now I have x minus 3 squared plus 0 plus 4, like I just said, squared is equal to 20. All right, so now clean this up. I have x minus 3 squared plus, well, 4 squared is going to get me 16 equals 20. I want to get that squared portion all by itself, so I'm going to take away the 16. So x minus 3 squared is equal to 4. So now I'm ready to solve by taking the square root. And x minus 3 equals plus or minus 2. I can add that 3 to the other side. So x is going to be equal to 3 plus or minus 2. So 3 plus 2 will be 5, and 3 minus 2 will be 1. So as points, I would say 5, 0, and 1, 0. Those would be the two x-intercepts. Okay, let's get the y-intercepts as well. We'll do those right next to it, right here. So my y-intercepts, those occur when x equals 0. So I'm going to plug in a 0 here for the x, which is going to make it negative 3 squared. I know that this whole part is going to end up being 9. All right, so 0 minus 3 squared plus y plus 4 squared equals 20. Like I said, negative 3 is a quantity being squared is going to get us to 9 plus y plus 4 as a quantity squared equals 20. Okay, take away the 9 from each side. And y plus 4 squared equals 11. Okay, I'm ready to solve by taking the square root. So now I have y plus 4 equals plus or minus the square root of 11. And then take that 4 away from each side. So y equals negative 4 plus or minus the square root of 11. So if I write those as points, I have 0, comma, negative 4 plus the square root of 11, and 0, comma, negative 4 minus the square root of 11. Now to graph those, though, I'm going to need their decimal approximations. So here, this first one, a negative 4 plus root 11 will get me 0, comma, negative 0.68. And the second one, 0, comma, negative 7.32. So again, that's just going to help me graph it more precisely. All right, I usually start by plotting my center. X marks the spot, so 3, negative 4, right here. And then my radius is 4.47, so I'm going to go up about 4.5. I'm going to go left about 4.5. I'm going to go down 4.5, and right 4.5. Okay, so I've used my radius. I've gone up, down, left, and right. Now I'll put in my x-intercepts. So 5, 0, and 1, 0, right there. Okay, and then my y-intercepts about 0 and negative 0.68. So we're right about there. And 0, comma, negative 7.32. So about right there. All right, so all looks good. I can connect my dots. I can freehand it, or you could take out your compass and make it a little bit more precise. It does not matter to me. All right, there we go. There's our beautiful circle. Next up, let me slide it up, and then let me zoom in a little bit tighter so you can see everything on the graph just a little bit more clearly. So prove or disprove the statement. The point 6, -4 lies on the circle centered at the origin and containing the point -5, 3√3. It might help to visualize using a graph. So that's why I gave you a grid, is just to help you visualize. Okay, so here, well, let's plot those points. We're saying, okay, this is a circle that is centered at the origin. And we're saying, well, these 2 points have to be on the same circle. So let's plot them. So 6, -4 would put me right about here. And then when I look at -5, 3√3, well, let's see, that's going to be, if I look at what's 3√3 approximately, that is about 5.2. So I'm looking at -5, and then I'm looking up 1, 2, 3, 4, 5.2, just to give myself a visual anchor. So there are those 2 points. Are they 2 points that could be on the same circle? Well, let's make ourselves a right triangle for both of them. Right? It means that the hypotenuse would have to be the same for both of them, which would really be the radius of the circle. So let me make 2 right triangles like this and see if we can get the radii to match. So here would be -5, and here would be 3√3. Here would be the 6 and the -4. All right, so I'm visualizing those 2 right triangles. So let's say I look at the one right here. Let's picture Pythagorean Theorem to get to that radius. So 3√3 squared plus 5 squared would equal the radius squared. So that's like saying 3 times 3 times 3, or 27, plus 25 equals the radius squared. Radius squared would be 52. Solve by taking the square root. We should know that 52 is 4 times 13, so 2√13. Technically, we're plus or minus in our algebra world, but geometrically, it's a measure, so we're interested in the positive. So the radius would be 2√13 for this one. So I would have a circle with a radius of 2√13, and I need this one to match if those points fall on the same circle. All right, so here I'm going to do the same thing. So 6 squared plus 4 squared equals r squared. 36 plus 16 equals r squared. R squared equals 52. Well, looky there, I see the same thing. I'm going to take the square root, break it down. I'm going to see that 2√13 again. So yes, I have proven it. The statement is true. Their radii match. We got the same radius value. So I'm just going to write proven. Success. Statement is true. The radii are the same. And of course, you know I like to box it. Okay, so let's look at that next problem right here. All right, write the standard equation of a circle with a center of -2, 5, and tangent to the x-axis. All right, that feels important. Tangent to the x-axis means it touches the x-axis right in that one spot. So touches the x-axis in one spot, one location. All right, so let's graph. So our center is -2, 5. So -2, 1, 2, 3, 4, and 5. All right, which one is my x-axis? My x-axis is right here. So let me emphasize that by highlighting that right here. So if I'm tangent to the x-axis, then the point of tangency would have to be right here at -2, 0. So that really clues me in that a radius right here would be my radius, would have to be 5. So the radius would be 5. Okay, so now I need to go from that center up 5, left 5, down 5, right 5 if I want to just visualize the full thing. So here I'm going to go up 5. I'm going to go left 5. I'm going to go right 5. All right, so if I'm picturing it, let me try to smooth out my curve. Again, if you wanted to take out your compass, you can make it look even prettier. All right, so there we go. So if we're writing our equation, right, our center, we know the center. We were given that as the -2, 5. So now I'm going to say x minus -2, so x plus 2 as a quantity squared, plus y minus 5 as a quantity squared is equal to the radius squared, and the radius is 5. So 5 squared gets us to 25. Okay, let's flip. All right, number 5. Determine whether the line is a tangent. So a tangent would mean that it's going to touch in one location, one point of intersection. A secant, so a secant would slice through the circle in 2 spots. A secant that contains the diameter, so I'm going to slice through the circle in 2 spots, but it passes through the center of the circle, or none of these. And again, it may help to visualize using a graph. So let's graph that circle first. So the circle has a radius of -2, 5. I'm sorry, not a radius, center of -2, 5, and a radius of 3. All right, so the center is -2, 5, and the radius is the square root of 9, so 3. Okay, so let's plot the center. So -2, 5, there, and the radius is 3. So I'm going to go up 3, I'm going to go left 3, I'm going to go down 3, and right 3. So here is my beautiful circle, just like that. Okay, my line, well, my line is presented in slope-intercept form. So y minus y1 equals m times x minus x1. So the point that it passes through, let's write it right here, would be -3, +3, with a slope of 2. All right, so if I plot a point at a -3, +3, right here, and then my slope is 2, I'm going to go up to right 1. Oh, look, passes through the center. Up to right 1, and just continue with that pattern. Then here we go. All right, so I can see that this is a secant because it passes through the circle in 2 spots, and it contains the diameter because it passes through the circle. So let me just write this off to the side. So this is a secant that contains the diameter. Again, we know that because we have 2 points of intersection. the circle. And contains the diameter because it passes through the center. All right, we should be good on 5. Let me zoom in a little tighter to get into 6. All right, so 6, I'm giving you a bunch of the different segment relationships. So when I look here, I see that I have 2 intersecting chords. So what I'm looking for are my smaller portions. I know that 4 times x is going to be equal to 8 times 6. So here it's the product of the smaller portions equal to the product of those other small portions. So again, 4 times x equals 8 times 6. So 4x equals 48. Divide both sides by 4, and I get that x equals 12. Easy enough. On to the next one. So here I see a tangent, so tangent secant combination. So I know it's going to be the tangent part right here squared, so x squared equals the whole, so I need the whole secant segment, that's 11, times the outside part, which is 5. So the tangent segment squared is equal to the whole times the outside. So now x squared is equal to 55. Solve by taking the square root. We know that that would mean, well, plus or minus the square root of 55. There's no pair in that. And we end up taking the positive because it's a measurement. So we're just saying that x is the square root of 55. All right, looking over here at C. In C, here I have 2 secants. So I know that I'm going to take the whole times the outside and make it equal to the whole times the outside of the other secant segment. So let's just mark what that whole part would be. For this one, that would be x plus 9. And for this one, it would be 6 plus 8, which is 14. So again, whole times outside equals whole times the outside. So on top, that means x plus 9 times x. And on bottom, that means 14 times 8. So I'm going to have to distribute that x out. So x squared plus 9x is equal to 112. Okay, you can see, oh, it's a quadratic equation. Let me pull that 112 to the other side. Let me subtract it over to the other side. So x squared plus 9x minus 112 equals 0. So now I'm looking for 2 numbers that multiply to a negative 112 that add to a positive 9. So that's got to be 16 and negative 7. So x plus 16 and x minus 7 all equal to 0. And then I take each factor, make it equal to 0. I solve, and I get that x equals negative 16 and x equals 7. Now, can't have a negative measurement. Doesn't work in geometry, so that negative 16 is out. Not going to work. It's an extraneous solution. We were able to solve for it, but when we plug it back in, it doesn't actually work. So the only one that works is the x equals 7. All right, next one right here. So here we see a circle that is inscribed inside of a triangle. And I have to connect the dots and get to x. So I have to remember that when I have 2 tangents, right, if I can connect their points of tangency, so visualize this for a moment, it creates an isosceles triangle. So my tangents end up being congruent. Their measures are equal. So if I build off that 4, right here has to be 4 also. And if this whole span is 13, well, 13 take away 4 is 9, which means this has to be 9. And if this whole span is 17, this is 9, well, this has to be 8, and boom, I can get to x. X would have to be 8 also. So when I have tangents to a circle, those tangents end up being congruent because they end up forming isosceles triangles. All right, next up, number 7, little angle and arc review. So here my goal is to get to x, but I can't connect to it right away. So let me keep my eye on the prize. This is what I want to get to, but it's not what I can connect right away. So let me look at what I can do right away. If I look at this 86 and I trace it up, I go, okay, I know that from here to here, this whole span, that vertex is on the circle. Its arc is going to be double the 86. So this whole span here is going to be 172. Okay, but I still want x, so I need to know, well, what's this sliver here? Can I take that away from the 172? Well, absolutely. Right here where this 70 is, its vertex is inside of the circle, so it's going to be the average of the two intercepted arcs. So if these are going to be 26, not even 36, 26 units apart, let me say that correctly, 26 units apart, well, these are going to be 26 units apart too. That's the nature of an average. So this would have to be 96. And if you don't like that method, remember you can say, well, 70 equals half of x plus 44, and you can get there the more algebraic way, that's fine. So let me just confirm that that's going to be 96. Right, I would double each side, multiply by 2. So 140 equals x plus 44. Take away that 44, and voila, right, we are confirmed that we got the 96 right there. So now to get to x, I'm just going to take that 172 and deduct the 96, and I end up with x at 76 degrees. All right, I got one more. So on to 8. All right, so here my goal is to get to LM. So again, my eye on the prize right here is what I want. I want from here to here. How do I get there? How do I build off of what's given? Well, I need to find HK first. I got to find this arc first, from here to here. Vertex is outside. I know that the angle is going to be 1/2 the difference between those two arcs. So I know that 40 is going to equal half of 168 minus x. Okay, double each side, right? Clear the fraction. So 80 equals 168 minus x. Take away the 168. So negative 88 equals a negative x, right? We can divide each side by a negative 1 and get that x is 88. So right here is 88 degrees. Okay, so I filled in one piece of the puzzle. Now I want to connect to get to that other arc right here. Here that vertex is right in the inside, right here inside of that circle. So I know that 78 has to be right in the middle of two numbers, right? It has to be equidistant because it's the average. And again, I can take that shortcut and say, oh, well, they're 10 units apart here, got to be 10 units apart here. Again, that's the nature of an average. So I can see that it's going to be 68 degrees, but just to confirm it, let me remind you, you can make an equation. Right, 78 is 1/2 the sum of, I'll call it y, and 88. Okay, clear the fraction, double each side. So 156 equals y plus 88. And then take away the 88 from each side. and y equals 68. So the measure of arc LM is going to be 68 degrees. All right, that's all I got for today. Have a lovely rest of your day.